Hello all, today in this video we are going to make a demo with the FTRL optimizer. Previously we made some other optimizers and this is the continuation of the previous video only. So we are moving some forward only. So if you are having any doubts means please let us know in the comment box. So initially we are importing the libraries which we are needed. Then we are just loading the data set. This data set we downloaded from Kaggle. You can just give us heart disease prediction Kaggle means you will get this data set. The data set which we have downloaded is having nearly 14 entries. Among that, the first 13 entries we are using as the x variable, and the last entry which is the target one we are using as the y variable, and then we are getting the information regarding the data set, and we come to know that only the old peak variable is the float type and all others are integers, and then we are describing our data set. Then we are checking whether our data set is having any null values. Since every entry is 0, it is noticed that it is not having any null values, and if it is having any null values means we have to work with some pre-processing functions. Then we are displaying the heat map of the data set. So this is the heat map of the heart disease prediction data set we are using. Then we are declaring x variable and y variable. Since apart from target, every variables are used in x variable, we are dropping a target variable from x and using all others from the data set, and within this y variable we are using only the target. Then by use of this x variable and y variable, and with the test size as 0.2, that is 20% for training and remaining 80%, 20% for testing and remaining 80% for training, and with the use of train test split function we are determining variables like xtrain, xtest, ytrain and ytest, and within the xtrain and xtest variable we are using the standard scalar to convert to vectors, and then we are getting the shape of the data. Why? Because we are using the shape within the CNN input shape. But mostly in CNN algorithm, that is the convolution 1D layer will take only the three-dimensional data as input. But here if you notice means we are having only two-dimensional data. So we have to convert our data into three-dimensional. For that we are using the reshape function. By using the reshape function, our data is converted into three-dimensional, and this three-dimensional data we are using as input within the convolution layer. Apart from xtrain, we are also reshaping the variables like xtrain and xtest and ytest. Then we are determining the layers for CNN. Within that, we are calling the sequential layer. Then the convolution layer, which is con1D, consisting of the filter size, kernel size, then padding, activation, and input shape, followed by max pooling layer with the pool size of 2, followed by the flattened layer. Then dense layer with the output dimension as 128 and activation as ReLU. Then a dropout with the dropout rate by 0.5, and then another final dense layer with the output dimension as 1. Why 1? Because here our work is a binary classification work. In binary classification work, we will give the dense layer output dimension as 1 only. If it is multi-class classification means based on the number of classes we will be replacing the dense layer output dimension, and mostly in the binary dimension classification work the activation will be sigmoid only, and then we are getting the summary of the convolution neural network model. Then we are compiling the CNN by using the loss as binary cross entropy, optimizer as Adam, and metrics as accuracy. Then we are training our model by using the fit function with variables like xtrain, ytrain, xtest and ytest, which is done for nearly 50 approaches. Then we are, if you notice means accuracy is greater than validation accuracy. If you see with this figure, you may notice that training accuracy is greater than validation accuracy. But for a better model, the validation accuracy should be only greater than training accuracy. For that, we are making some steps. Before that, we are declaring the classification report and also defining the confusion matrix plot, and we have got the confusion matrix plot. to for improve the validation accuracy, here in this code we are just decreasing the dropout rate. Initially we have given as 0.5 and now we have given as 0.51. By this difference you may notice that the validation accuracy is higher when compared to this training accuracy. Here you may notice here more or less it is same only, and then we have displayed the classification report and also the confusion matrix. And with the different optimizers we have worked. When working with the different optimizers, the only difference you may notice is that in place of optimizer previously we will be using adam, but as the name of the optimizer varies, we have to just vary it name, and all others are same only. It will work for 50 approaches. We are displaying the classification report and confusion matrix. Then with rmsprop, the only difference is we will be replacing the optimizer and we are displaying the classification report and confusion matrix. Then we worked with adadelta optimizer by replacing the optimizer. Then we are displaying the classification report and also the confusion matrix. Then we worked with adagrad. For that we are replacing the optimizer name with adagrad and we are working for nearly 50 approaches, and we have displayed the classification report and have also got the confusion matrix. Then we have worked with adamax. For that we are just replacing the optimizer name by adamax and we have displayed the classification report and also the confusion matrix. Then we worked with an nadam by replacing the optimizer by adam and worked for nearly 50 approaches, and we have displayed the classification report and also the confusion matrix. In this code we have worked with FTRL, so the same layer contribution we have used. Then we have replaced the optimizer and FTRL and worked with our model for nearly 50 approaches. By this you may notice that the classification report we got only 48% accuracy, and the confusion matrix graph is also displayed. So this is the confusion matrix graph of this ADAB. Then we are just making an comparison model. So within the comparison model you may notice that the now we have worked with the FTRL. So this FT RL, it will be showing some, I think it has not run. So in the next video we will make this comparison graph. So we will also working with some other optimizers. Thank you.